Alright, Assalamualaikum and very good day everyone. So today we are going to do our first practical lab, which is on truss or beam element. So you can get this worksheet from your VLE, and then we're gonna go through this worksheet. So what we're doing is we are actually designing your own car or SUV or truck chassis. However, you are going to be using tubular structure tubes. So you need to select your own tube diameter and make sure you get the proper thickness. And then a few things that you need to determine Number one is you need to determine the bending stiffness of the chassis, and then torsional rigidity of the chassis, and also determine the load condition, the stress and deflection on the chassis under suitable passenger and engine load So make sure you use the same material, which is steel, using the properties that you get from this page So number one, you need to get a reference of the car, the vehicle that you are going to use as your chassis. So you can go to Google and look up some maybe formula SAE chassis. So these are some reference images that you may be able to use as your vehicle chassis, because Formula student or Formula SAE cars, or the one in Malaysia is IMA race cars, they are custom made. So the chassis typically is constructed by for example this one, it's typically constructed using tube structure. So this is one example, modeling of a chassis of an SAE formula car. You can use this as a reference So over here they are even producing the reference this one is in Cornell University. In 1999, the weight is about 25 kilo and torsional stiffness is about 2169 Newton meter per degrees. This is the chassis rigidity. So how do they design this chassis? It is some sort of like this. This is how it looks like. It's a single passenger. You've got your engine at the rear, and then seems like the exhaust is going up. They have the pedal mount in the front, and then I think this one is an impact attenuator, something that can absorb any crash impact. So you can use this one as a reference, or you can search your own. However, there needs to be some sort of reference on the dimension. If you have the dimension, it will be very, very good. So how do you design this tubular chassis? Another thing that you can do is you can go to this website, drawingdatabase.com. So drawingdatabase.com is a place where you can get a lot of drawings which is in blueprint. So what I mean by blueprint is that you can get the actual car's dimension. For example, this one, we're looking at some cars dimension. The overall length is 4,768. So this is one of the things that you can gather here. So you can search any car that you like, and you can create a custom chassis. For example, currently I'm looking at this Toyota Land Cruiser 1987. So let's say if I want to create an SUV with a custom design, so I might be able to use this. So the good thing is that you have all these dimensions lah. So number one, you can snip out this whole picture of the side profile of the car and make sure you can save the snip, save it to your desktop. Toyota. So we're gonna model the whole vehicle, the chassis. So you can go to your SolidWorks, create file, new, and then create a new part. Click on OK. And then we are going to go to the features tab, and then click on one of the plane, which is front plane. And then you're going to right click and then click sketch. So over here you're going to go to tools and then select sketch tool and then go all the way down to sketch picture. And then you're going to find out where is your photo just now, Toyota. So this is my photo that I want to sketch. So if you look here, there is this blue color thing. So this blue color thing is actually a ruler. So you might want to click on the ruler. How do you click the ruler? If you are unable to click the ruler, you have to resize a bit your photo. How do I resize my photo? Okay, over here. Resize your photo in order to grab the ruler. Now I can grab my ruler already. Can I grab this end? Cannot. So resize your photo again. Now I can grab this end. And then I can make sure it is that particular dimension. So this is the icon that will come out if you click on this ruler. Right now you can cancel it first. Click on the ruler again. Make sure it is catching the dimension of your photo. Make sure it is the same length. So this thing will come out again. So now you are going to adjust the dimension of the ruler according to the photo. So this one is 4060. So make sure you key in 4060. So this will be the distance. So right now, if I were to sketch anything, it will follow 4060 mm, the size. So I'm going to click on OK. So if you're not sure, you can click on a line or something and then grab it there. So it's around that size, right? If you click on Smart Dimension, it will follow exactly lah. It will follow exactly the length of your photo. So what you guys are doing is that you are getting a JPEG, and then that JPEG you put inside your CAD, and then you can replicate. So this is useful if you need to reverse engineering an old drawing where you don't have any reference. You only have the printouts. So this is useful. So on the sketch here, you can again sketch a simple chassis. I have to stress this. A simple chassis, a rectangular shape. Don't sketch anything fancy following the total profile, no. Just do a simple rectangular box shape. So once you've done that, this is a rectangular box shaped chassis, and then I can exit my sketch. Afterwards, I can click on the sketch and then extrude. So how much should I extrude? I should extrude to the dimension. So the width of the vehicle is 1690 lah. So I should extrude by 1690. So make sure your units are okay. If your units are not okay, you have to change here lah. Make sure it is millimeter. You can go custom or just change this one lah. Millimeter, gram, second. This one is the same lah. mmgs. Millimeter, gram, second. So this is my chassis shape. So next thing, we are going to convert this rectangular shape into a tubular structure. So how I do that? I can go to sketch and then hit this icon and click over here, and I'm going to click on 3D sketch. So once this 3D sketch icon is here, I'm going to click on a line, for example this line, and then click my keyboard, which is Control A. So once I do that, it will select the whole lines, whatever it is in your CAD that you have, geometry that you have drawn. And then I'm going to click Convert Entities. So the whole lines will be darkened. You will become dark like this. So now I can exit my sketch, click this icon, and then if I click on 3D sketch, it is there lah. Now I can hide lah. Boss extrude, I can right click and then click hide. So my sketch in 3D is already there lah. So this is important that I have this. So now I can add more structural members. For example, I want to add one more line here. I can go to sketch and then 3D sketch. I can grab a line. Maybe I need to add some reinforcement here and then hit escape. One more time. Line, straight line. So I add some reinforcement ribs. So I can do this by utilizing sketch in 3D. For example, if you want to stiffen diagonally also, you can do that. If you look at Formula SAE chassis, they do a lot of diagonal reinforcement. For example, at the bottom. So you can do that also if you want. Maybe some members, this one to this point, maybe another point here to here, and then continue, I think cross and then over here to here. So maybe I have something like that maybe. So how do you use sketch in 3D? You can actually, for example, I want to sketch something here. This is actually in the XY plane. So it says here XY. I can change the plane by clicking tab on your keyboard. Click tab. So it's going to change to YZ now. And then click tab again, it's going to go to another plane, which is ZX. So clicking tab to change your planes if you need to do so . So currently I'm satisfied with this one. Don't put too many tubes. I'm going to exit with sketch. And finally I'm going to go to, I don't have this thing here. Features, I should be right clicking on one of the tabs here, right click. And then make sure I hit weldments. So weldment will be popped out here. I'm going to put some tubes inside my structure. So I just hit structural member, choose ISO. This one I will choose pipe. The size I'm going to change the biggest one I have here, 33.7 mm diameter. And now I can convert my structure into some tube forms. So this is like, for example, you need to weld. Let's say I want to start with the top, and then make sure you continue welding your structure into one pair, one whole solid. Why do we need to do this? Because there will be some sort of like a miter cut at the end. So that's why you have to continue doing. If I choose this one, I don't think I can do that. So I can't go any further unless I click new group. So the other group will be, I want to weld here, here and here. And then if I click again, I don't think I can. I need to click a new group. New group here, welding. It has to some sort of like close profile. And then new group, all bottom structures, new group. Then new group, this one, the rear one. Can I do this thing cross? I can't. New group. New group again. New group again. I think last one. So I've got my tubular structure here lah. So if you really look at it, it is how it is supposed to be lah, when it is joined like that. Oh, I forgot a few things here. If you've forgot a few pipes that you need to do, you can always go back here and then right click, edit feature, create a new group, and then this one, and then finally I'm okay. So this is tubular structure lah. If you need to change the diameter of the pipes, you can go to here and then click on sketch lah. For example, sketch 11. And then this thing will come out, and then you hit Control 8, and then you can change the diameter lah. For example, I want to change to 33.7. Let's say I want to change to 50. And this one maybe 40. So I'm making the tube bigger, and then I exit my sketch, and then the whole structure will be changed lah. The diameter, it's become bigger already. So it's easy for you to change your design to whatever diameter or whatever thickness of the tube lah. So this is very useful if you need to do any welding lah. So I should probably save my file here. Desktop, Toyota. So another additional item that you can do is, for example, you can so this is your thing lah. This is your vehicle. So let's move on and continue and do analysis. So in order to turn on analysis portion of your SolidWorks, click on SolidWorks add-ins. If this is not even available, you can right click anywhere, make sure you hit this one lah, SolidWorks add-ins. So under SolidWorks add-ins, you click on simulation. So simulation will be included lah in your add-ins. So this thing has popped up. So click this one, and then you are going to click on new study, and then choose static. Click on OK. So this thing has been converted to some nodes here. So if you look at this part, which is my part name lah, which is Toyota, under here there's a cut list. Under all these cut lists, and I can expand here, there's a solid body lah. So this solid body is actually available. If I turn on back here, solid body, turn it on, right, it's going to be there lah. Now if I go back to here, the solid body is actually there. So it's not been removed yet from your analysis. So in order to remove this solid body from your analysis, you need to click the solid body and then right click, and then make sure you click exclude from analysis. So if you include this thing, this will be a solid 3D analysis lah, not a beam analysis. So make sure you click exclude. So the whole thing will be excluded lah. Model view is still here. Right click and hide them. So go back to your finite element analysis. Number 1, hide the solid body. Number 2, we need to assign material lah. So you have so many pipes. Click on all of them. Right click. I cannot right click. I have to expand lah. Oh, this is going to take some time. How can I do this? Right click. Apply material. Yeah, I can do this. Apply material to all bodies. I don't need to select all my one. Just right click here. Apply material to all bodies. What kind of material do you want to put? By right, you should choose something here, or you can create your own lah. If you want to create your own, you can go to certain folder, for example custom materials folder, click expand. I can create a new library, for example my materials. Under custom material, alamak, plastic, custom plastic. This is my materials folder. I can click here, right click, new library, sort by material. Okay lah, new library called metals. Is it here? No, it's under here. New category, new library, sort by material. I don't know how do I expand the folder, because you need to go to certain folders only you can do. My material, I guess new category code. Okay, new category, metals. Then you can right click and then create a new material. So this is a new material. Click on maybe mild steel, general steel. So this general steel, you key in the value lah. What should be the value? The value should be here, 210 GPa. Elastic modulus 210 E9. Okay. Poisson ratio 0.3. 0.3. I don't need shear modulus. I can actually remove this one lah. I don't even need tensile strength. The thing that you need is the ones which is red color lah. But tensile strength is good to have. Yield strength is good to have. What is the shear modulus? I don't know. Mass density 7,800. 7800 kilogram per meter cube. This one is good. Tensile strength. Do I have a data for tensile strength? Yield strength is slightly lower. Let's say this one is 240 E6. 240 megapascal. And then tensile strength 300 E6. Something like that. So this is, you gotta save it. Save. Steel, under metal, steel. Click on apply. If you click on apply, you have applied your material lah. If you click on here, you're gonna see, yeah, solid body, and then there's an end here called steel. So every material has been assigned properly. So you have assigned your material. So you gotta work on the list lah. So from the top to the bottom. So my part is okay. Do I have a joint group? No. Do I need connection? No. Component contacts? Not yet. So I need to go to fixture. Right click. Click on fixed geometry. Under fixed geometry, you need to choose use reference geometry. And then what is your reference geometry? So it's asking you what are the joints lah. So let's say you want to hold it for at the front and at the back. So I want to choose this one, and this one, and this one. All these 4 joints should not move anywhere. By referencing a front plane lah, easiest. Choose front plane. Front plane is like the plane facing you guys lah. So click this one 0, this one 0, and this one 0. So the whole thing does not move lah. It's like you're being fixed like a tire lah, front tire and rear tire. And then click on OK. So make sure you select 4 joints and a reference front plane, and it doesn't move in any direction lah. So click OK. So you can see here, can you see the green color thing? It's actually being held like that lah. I can make this one slightly bigger lah. If I go to simulation and options, go to default option, load and fixture, I can increase the size lah. Fixture green color, right? I can increase the size 500. Click on OK. Is this thing be increased? It will be increased, but I think I have to do again. Fixture. This is the geometry lah. I think if I do another fixture, it will be refreshed. Make it bigger. I don't want to do it again. Should I try? Okay, let's try. You don't have to do this. Delete the fixture just now. Do it again. Right click fixture. Fix geometry. Use reference geometry. Choose the front plane. And then I can select my joints 1, 2, 3, 4. And then everything is 0, 0, and 0. Now you can see. You can see clearly the joints where I have fixed to make it not moving, like in a tire. So it is rigid lah in that sense. Okay, so what should I do now? Next, I should put some loads lah. For example, external load. Right click, click on force, and then again your force should be on. Currently I have beams, or I can put the force at the joints. Let's say I want to put the force at the joints, so I'm going to select some joints now. One here, and then another one here. So I have 2 forces. Reference plane, still my front plane. The force is going this way, reverse direction. How much is the force? Let's say I'm putting 1000 Newton. So since I'm putting 1000 Newton, I have 2 points. So 2000 Newton lah, the load I am putting at my car. So this is the option you have if you choose joints lah. If you want to choose, for example, beams, you can select the whole beam along the plane direction 2. Along the plane direction 2. So I choose this one. No. Let's try. How does it look? I don't get any vector. Select a reference plane. Okay, I haven't selected a reference plane. Front plane. Okay, now this is good. So you can apply forces at the joints, or you can apply forces at the beams. So this one, even though you can see 4 arrows, the whole total is 1,000 Newton. It's different from joints. So either one is okay. Click on OK. So this is the boundary condition that I have. Finally, you can mesh. Right click, click on create mesh. So currently it's being defaulted with this mesh size. You can change if you want. You can click on details. So I have about 447 nodes and 435 elements. Can I create? You can create some, you can apply some mesh control. For example, I want to simplify certain area or make sure certain area has a higher density mesh. You can click on it. So you can do all that lah. There are many other items that you can click here. Can you create a mesh plot? What for? Creating a mesh plot is a way for you to see the quality of the mesh lah. But currently it's just beam element. It's not very relevant yet. Once we go to 3D, then this is very important lah. Right click, you can delete. Other things you can do is that you can check for your solver. For example, you can click on properties here. So this is the static analysis, right? This is under static. Right click, click on properties. What are the items you want to put here? Do you want to put large displacement? If this is important, you can hit large displacement lah, but currently no, we're just going with the default version values only. So maybe you want to save before you run, and then click run this. So this is the structure look like under load. So I can do some things here. Go to stress, right click, click on edit definition. So number one is that you want to change your stress value into megapascal. There are certain things here. This is the averaging probably. Oh no, this is the data. Upper bound, axial and bending. So currently the default deform shape is 141x. This is not actually a true scale. If you click true scale and then click on OK, you cannot see any deformation. It is like that. So go back, stress 1, edit definition. You can maybe see 10x. Can you see any deformation? Slightly, right? Cannot really see. Right click, edit definition again. You have to enlarge maybe 100x, then you can see some deformation on the structure. This is done to help engineers solve problems. For example, I can see there's a lot of bending here on this roof frame. So this roof frame is not getting enough reinforcement. I cannot see that if I'm looking at a real deformation scale factor. So edit definition again, change a few things, megapascal, and then go to property setting, chart options. You can change this one to normal, this one to general, and then go to settings. Make sure your fringe option is changed to discrete. So continuous plot doesn't have any boundary between the values. Change to discrete, and then click on OK. So you can see over here, My yield strength is 240 lah. I am only getting some maximum stress that's about 19.6 megapascal. So I'm not in trouble yet, but then my load is only 1000 Newton. 1000 Newton is like 100 kilo. So next, let's look at displacement. Right click and then click on show. Where am I getting my greatest displacement? The greatest displacement is actually on this beam lah, but this one is localized deflection. If you really want to look at the maximum deflection at the bottom, how do I do that? Yeah, I gotta look at, you can hit tab and then rotate. Look at the views that you need. Right. If you're in isometric view, click on spacebar and then hit the surface that you want to look. If I want to see this lowest deflection of this main beam, I can click on plot tools and then I can hit probe. Oh, it's not deflecting anymore. Maybe here or somewhere. Show, edit definition, automatic 141. Why is it not deflecting? Result. Animate. Can I animate? Cannot see anything. Right click displacement, right click stress and show. It is deforming. If I show displacement, it's not deforming. I guess I have to edit the definition, change to, I don't know, deform shape. Oh, I can click deform shape and then click on OK. Oh, then it will show. So I would say the biggest deflection I see is here, over here somewhere. So click on plot tools, probe. It's not there. Click this item lah. Okay, never mind. The result is about 1.7 mm. 1.7 mm. When I apply 1000 Newton, I get 1.7 mm. So let's try to calculate the bending stiffness. Okay, let's take a look at our results. So, stiffness, K, or rather we start here. F is equal to Kx. K is the stiffness, is equal to F over X. So, force, how much force am I applying? I applied 1000 Newton. I got to draw somewhere here. So K is equal to 1000 divided by 1.787 mm. 1.787 times 10 to the power of negative 3 lah. So now I can get, so put it in your calculator. 1000 divided by 1.787, 10 to the power of negative 3. So I am getting 559 kilonewton per meter. Right. 559 kilonewton per meter. So this is the bending stiffness. Of course, if you really want to improve certain things, you can modify your designs lah. Right, so this is my current design. You are getting some problems at this beam, right? You don't have to do any modification to improve it yet lah, but if you want to do so, you can just go back to model and then 3D sketch, or this 3D sketch, right click this one lah. You can add more beams lah probably, or change this one to a bigger diameter. Obviously I cannot put a beam at the center here lah. Let's say you want to improve some torsional rigidity, you want to put this beam diagonally here to here. Click on OK. And then of course you can exit sketch mode. Go back to your weldment, create a structural member again. Oh, this is a very tiny This is very tiny, why? I haven't changed the diameter of this profile. Never mind, you can do that later. If you go back to static, the whole thing will be included lah inside. But remember, you have to create a new mesh. Create mesh. Because you added new member in the structure, you have to remesh again. Then you can run it again. Material is not defined for this part. Right click Toyota, apply materials to all bodies, choose your material lah under my materials, metals, steel. Apply, close, run this analysis again. Can you see any improvement in terms of displacement? Probably not, because that is not where the area that you improve. 1.229. 1.229, yeah, improve a bit. 1.229 mm. Just now it was 1.78, so it has improved the structural rigidity a bit lah. This cross member. Okay, remember we are doing this Land Cruiser So SUV tubular structure, is it available? I don't know whether people design this or not. Yeah, there is people doing this one. Tubular structure for a big car. Okay, so that's all on the practical lab lah. For torsional rigidity, this is slightly harder lah. You can choose to do this, but then you have to measure the angles lah. I guess this one you don't have to do lah, torsional rigidity. Slightly harder lah. You do the third one, which is the stress and deflection under passenger and engine load. So you can, this one you can apply certain forces on the structure itself lah. How much force? What is the passenger load? Or maybe you want to put the overall load. Just put somewhere lah. Okay, so that's all. And just put screenshot your results. These are some guidelines lah, what you're supposed to write. Then screenshot your results, put it in here, and then you can submit lah. Make sure you put your name on this page. You can submit using this very PowerPoint, or you can do another document if you want. Depends on you lah.